as input, right? That just doesn't make sense. You can't find the prime factors of negative 5. Right? And so here, in the second example, we use the short-circuiting operator. We say, is x greater than 0 and factor x? And it says false, right? Because it's saying, is this first thing true? No. So I'm not even going to bother trying to compute the second, and thus returning an error. I'm just going to say, well, the first thing is true. I know the rest has to be, the first thing is false. It's an and. It's not even worth our time to check the rest of it. The whole thing is false. And so that's short-circuiting. And so short-circuiting is used primarily in special cases. Involves creative programmers can use short-circuiting quite a bit. So it's sometimes very helpful with your error checks, but you can get by without really using short-circuiting if you really don't want to, although I think it's very good to know how it works and what it does. Okay. So now let's start looking at taking these logical decision-making, is it true, is it false, and putting them into action. And so there's a statement in basically every computer programming language called if. And if works as follows. You say if, and then you give some condition. And the condition has to evaluate the true or false. 1 or 0. If the condition evaluates the true, MATLAB will go and execute whatever these statements are. This can be one or more lines of MATLAB code. However, if the condition evaluates the false, MATLAB doesn't execute those statements. So it just doesn't do anything. So it's basically making a decision. If some condition is true, I'll do these, MATLAB statements. I'll execute them. If the condition's false, I'm just going to skip over those lines and pretend they're not there. Right? And so we're going to use a hockey example. And what I hope basically happens this season. Let's say the New Jersey Devils, we have their ranking equal to 1. So our variable ranking is 1. And then we can have an if statement. And we'll pretend we didn't know the ranking before. We say, if the ranking is less than or equal to 8, display the team made the playoffs. Right? So in this case, MATLAB will do that. It will, in fact, display your team made the playoffs. So, great. Marty Brodeur and company are going to win the Stanley Cup this year. Fantastic. And it's all because of our MATLAB if statement. However, if we switch this around a little bit, right, and say, instead of ranking equals 1, like ranking equals 10, we could say, if the ranking is less than or equal to 8, display your team made the playoffs. Well, the ranking is not less than or equal to 8. This is false. Therefore, MATLAB is not going to do this. It just kind of says, okay, this is false. I'll go on with my program. So if there were more lines of MATLAB code down here, it would continue on with the program with that. So conditional basically says, if something's true, and then do all the MATLAB statements until we reach an end. Right? So don't forget the end. Right. So now let's say we wanted to make a slightly more complicated conditional. We want to say, if something... here's actually some more examples. Sorry about that. We can have a conditional that says, if x is bigger than 15, display x as a big number. So if x were 20, MATLAB would in fact display that x is a big number. If, however, x were 10, MATLAB wouldn't display anything. Right? And then also here's another example. And you're going to start to see now that, basically from now on in the course, there's more than one way to program anything. So we could say, well, if we were curious if, the variable x just wasn't 20, we could say if x is not equal to 20, display x is not 20. And then here, we have an example that does the exact same thing. If not x equals 20. Basically, so let's think about this. If x is 20 in this first example, up here, then so x is 20, this whole thing is false. So if x is 20, the whole thing is false. If x is anything else, it's true. Right? So down here, let's look only at the inside part for now. If x is 20, then it's true. However, the not at the front reverses true and false. So if x is 20, the whole thing becomes false. If x is anything but 20, on the inside, it'll say, oh, this is false, 0, x is not 20. But then the not reverses it, and so anything else than 20 would be true. So there's more than one way to do just about anything in computer programming. So now let's go expand this a little bit. We can have what's called an if-else statement. And an if-else basically lets us decide between two courses of action depending on whether a conditional is true. Right, so we can say if some condition is true, T-R-U-E, we'll do these statements. However, if the condition is false, we'll do these statements. So if the condition is true, we'll do this. Else, we'll do this. So notice, basically, we have two sets of statements, 1 and 2. And if it's true, we'll do the first set, but not the second. If the condition's false, we'll do the second set, but not the first. We never do both. Right? So here we can do an example. We can say if the ranking, let's say ranking's 1. And we'll just, pretend we didn't know that. If ranking is less than or equal to 8, display the team made the playoffs. Otherwise, else, say you did not make the playoffs, sucks. Right? So this is, kind of, I guess, what you would call the Devils option, and this is what you would call the Rangers option. Except my tablet doesn't want to write suddenly. I guess it's mad at me for making fun of the Rangers.